Foundation Engineering Limited have combined with Études et Travaux des Fondations in the United Kingdom a new method of installing watertight cut-offs. A method invented and patented by Raymond Maillard, Ingénieur Civil des Mines. Already, this system has been extensively used in Europe, notably under construction of watertight banks for raising sections of the Upper Danube and the Moselle. The ETFE system provides a grout barrier in the earth, which is more waterproof and much cheaper to construct than a conventional curtain of sheet piles. Here, in simple diagram form, is how the system works. A series of specially reinforced H-section steel piles have been driven shoulder to shoulder into the ground. The speed of driving varies according to the strata the pile is penetrating. Driving continues until it is finally embedded in the impermeable clay. At the other end of the series, the rearmost pile is being extracted. As the pile rises, grout is pumped down the pipe which is welded into it. The grout, under pressure, fills the void in the earth created by the withdrawal of the pile. This pile is then leapfrogged to the leading edge of the series to be driven once again. At the same time, the now rearmost pile is being withdrawn, and so the cycle of operations is continued. This system was used for the first time in England at the Offord intake works on the River Ouse. The screen forms an impermeable barrier preventing the flow of groundwater from the surrounding gravel into the pound and vice versa. Thus, it serves as a construction expedient in addition to its purpose as a permanent cut-off. The unit consists of a piling rig equipped with hydraulic jack extractors mounted on a self-propelled chassis which also carries a tower crane for repitching the withdrawn piles. On this job, 7 H-section piles were used. They are driven by a Delmag D12 diesel hammer and withdrawn by hydraulic extractors. As the pile is extracted, the pressure of the grout and the movement of the pile breaks down any fillets of earth which may remain between adjacent piles. The unit rests on a length of rail track. When the limit of its travel has been reached, it raises itself on hydraulic jacks and advances the tracks. Finally, the jacks are lowered, thereby settling back the chassis upon the track, ready to continue its progress. This excavation, which is some 25 feet below water level, is completely dry, apart from the residual water trapped within the screen. In Europe, so far, over 1,150,000 square yards of cut-off have been constructed. The average depth of the work has been about 23 feet. But without varying the procedure, it is possible to make continuous screens of the same nature to a depth approaching 50 feet. The process is economical because it uses a minimum quantity of a cheap, impermeable material to form the cut-off. It's effective because it is continuous, and it is inherent in the process that the grout penetrates furthest and most easily where it is most needed.